morning, everybody. I'm Dan. As he mentioned, I am that guy that made Appium. I also did some other things at some point. And I'm here today to talk about architecture of mobile test automation, which is something I know a little bit about. Also, that's my Twitter handle if you want to follow me. Or if someone could take a decent photo of me, like that would be amazing because I can't get a decent. That's like from 5 years ago, and it's not. It's okay. But I would like something more recent. So just tweet it at me, and I may make it my LinkedIn photo, and maybe I'll send you a T-shirt or something. Yeah. So I guess previously I worked at Shazam. I guess we know what that is. A company called. Why am I looking? I know where I worked. Why am I reading the slides? I worked at a dating site in America called Zeus, which sounds like a German word, but I don't think it is. I don't know if it's very popular here. But I believe it's the second highest grossing app all time in the App Store behind Skype. It's a very popular dating site. And then before that I worked on Outlook and Excel at Microsoft. First I wanted to talk about the scope of mobile test automation. So there's sort of different kinds of things we consider test automation. The first is one Appium falls into, which would be UI automation or functional test automation, where you mimic or emulate user scenarios through GUI automation or something like that. One tool in the box, if you guys have heard of the testing pyramid, it's sort of on the top where you want very few of these tests, but they need to cover very important scenarios. There's also unit testing, which is sort of on the other side where you want lots of these and they'll cover individual sort of aspects of your code, but they're not GUI automation, they're usually more validating. I always look at unit tests more like you code the spec into the code, so all the things that you're supposed to do, you now have tests that prove that it does that. There's also things like performance automation, measuring redraw rates, measuring bandwidth usage, battery usage, all those kind of things. And then there's just app instrumentation, so checking for crash logs and other silly things like that. I guess when you're building a mobile test automation framework, the first question that I guess you need to answer is, how are you going to control the app? And so there are many different ways to do it, but when we were looking at Appium, these are some of the things that came up. We use vendor-provided APIs. We do this because we would like our product to work when Apple or Google or Microsoft or BlackBerry changes the version. So if you use the APIs provided by the vendors, they're well documented, they are supported. Other tools have gone a different route and use private APIs. So Apple does have, under the hood, there's a layer of C private APIs where if you get the magic header files, you have access to all sorts of fun things. These have proven to be quite effective and actually not as brittle as they should be, as Apple doesn't rewrite their whole foundation of iOS very often or change it that much. And so there are some great tools that do it that way. Sort of on a different aspect, there's the idea of operating system level control versus application level control. So on Appium, we have actually now, pretty soon, both of them will be moved to operating system level control. And I'll get into why one is better than the other in a little bit. And then, the other means by which you can control things is sort of external hardware. And I'm hinting that there'll be a fun demo about that later. So, what are the pros of using vendor APIs? They're going to work, they're well documented, and like I said, Apple will change them and you can change and they'll still work. On the downside, they don't do everything. So on iOS, in the official framework, there's no way to hit the home button. There's no way to switch applications. There's no way to change to a phone call. None of these things exist. There's some other things, just really obvious things you want to do is testing, like set the battery level or silly things like that you can't do. Android's much nicer and you can do most of that in the framework. It may not sort of fit what you want to do with the tool. You're sort of locked in. So something like Espresso is an asynchronous framework. And if you're writing something, if you're writing test scripts in, there's a bit of a reach around, I guess, to sort of pull that off. You're also sort of reliant on the vendor to fix bugs, which you think wouldn't be that hard, but it is. Apple never reads anything we send them, I swear. I guess you're also sort of limiting yourself to one programming language. Usually, Apple now provides Swift and Objective-C versions of their automation framework as of Xcode 7 and iOS 9. In the past, it was always JavaScript, which seemed a bit random. But anyways, that's sort of one of the things you're doing. Now, when you go the other route, like tools like Frank and Calabash and Kif do, you can expose a lot of fun stuff that they didn't have time to put in the framework. And honestly, it can be built more reliable in the short term, I think. In the long term, the tools do need to be updated, but as long as they update them, you get that reliability downstream, right? The downside is there's no documentation for these private APIs. It's sort of guess and check, figure out what they do. And you're not going to get any issues fixed on these because Apple will just send you a mail. They probably won't send you a mail, but they'll just say, why are you using these undocumented APIs? It's none of your business. Something I mentioned earlier, the point of control is also important. So the previous versions of the iOS framework, UI automation, had application level control, or sandboxing, I guess is another way to look at it. Whereas with their framework, you were only allowed to control elements within your application. So things like the home button or logging into Facebook are completely out of scope here. You're locked into your one little app. So there's things you can't test, like logging into Facebook, or you have to come up with a creative workaround where you can sort of web view into your app and log into Facebook or something silly like that. But it can be very frustrating. When you have operating system level control, it's sort of like you have the whole device and the whole ecosystem. So if you need to add a contact to your contacts to use in your test, you have access to do that now. UI Automator for Android has always been this way, and finally, thanks to some smart guys at Facebook, we found a way to make it true for iOS as well, which is coming in a later version of Appium, hopefully in the next few weeks. So anyways, that's all I'll say about that. And I guess lastly, about sort of the programming aspect of it. So people are going to have to use your API, right? So these are sort of things you think about. Do you want to reuse some known protocol or create a new API, right? So in the case of Appium, we reused the Selenium protocol, which is something people already knew. Because we did that, we got a lot of stuff for free, but I'll go into that in a second. You can also say, are you going to support one language or many languages? When we chose Selenium, we got every language Selenium had bindings for free, which is about a dozen of them. Some other things to think about: async versus sync, and then client server versus embedded. Espresso is an embedded framework. It runs inside the application. Calabash and Frank, you have to install an SDK sort of into your app. They're kind of client server too, but they're really embedded. Something like Robotium, you actually build the test into your source code. That's an example of embedded. Appium, Selenium, those are client server sort of tools. So reusing existing protocol, some of the nice things are you get users that are just ready to go. They don't need to learn anything. They already know how to do Selenium, right? You know Selenium, you know Appium, they're the same thing. There's a lot less work to get going because there's all sorts of helper libraries for Selenium. There's a Jenkins plugin for it. There's a JUnit plugin for it, whatever, right? It's all there. So it already integrates with the rest of the ecosystem. And you sort of also just get to sort of leverage or piggyback on the trust that people already have with that tool. When you create a new API, people aren't entirely sure what is it going to work, are people going to like it. When you do something that's already been done before, you get that familiarity, which is really nice. And then on the con side, things can feel forced or awkward, I guess. So, you know, in the idea of a mobile application, there are things that don't exactly map to the web paradigm. Selenium is a web tool, and it has things like page source, which there isn't exactly a page source on a mobile application most of the time. There is a DOM, and so that's sort of an analogy you have to make. But there's some other sort of less obvious ones that were made. For example, web pages have frames, and we ended up having context in Appium, which is sort of like frames, but different. So by not controlling the protocol, it may make it a little confusing for users. And then lastly, if you need anything changed, you actually need to talk to the people that change it. And I won't say anything bad about the Selenium project, but they don't exactly move the fastest of any project I've ever seen. Anyway, so on the other hand, you could create a wholly new API, like Calabash has done. So you can write beautiful test code exactly as you like it. You can design it however you want. If you want to make it promises-based, you can make it promises-based. If you want to make it async, you can make it async. If you want to have, you know, individual commands for individual things, you're in control. You know, the canvas is clear. There's low friction here. You're in total control. On the downside, you have no users built in, right? You walk into an environment where no one knows what you are and you're constantly explaining it to them. There's a lot more code to write in that case. We wanted to support Ruby. Selenium already did that, so that was no work for us. If you want to support Ruby, you need to write it and find a Ruby guy. Integrations with other tools you're going to have to do as well. And like I said, you don't have that existing trust with users. And if anyone wants to use your framework, they're going to have to port all of their existing tests. There are a few other tools, mobile tools like iOS drivers, Android, and a few others that use the Selenium protocol. So people who use those tools can freely move between Appium and those tools, which is really nice for them. So it's a lot easier to sort of poach users from those groups, or vice versa, right? So I was initially going to do a whole half hour on mobile test automation stuff, but I just wanted to cover it very quickly because last week I ran into this guy at a conference. He saw me bring something to it, and he wanted me to bring it for you guys today. And so I have brought it. It was kind of a fun demo that did not work a week ago. Funny story. You guys are testers. You'll laugh at this. There we go. So I'll explain this in a second. But to run Appium on a phone, you need iOS developer certificates. And to get iOS developer certificates, you need to pay your bill. And when you sign up for the App Store program in the Pacific time zone, as I did, it rolls over at midnight Pacific, which is 9 a.m. in Berlin. So when you test it in your hotel room at 7 a.m., you're still an iOS developer. And by 9:45 a.m. when you give your talk, you are no longer a registered iOS developer. And you get a cryptic error message. So I have now paid my bill. And I'm now once again a member of the Apple Developer Program. So this should go pretty well. But it did not last time, and I could not figure it out why. But there was a 30-day warning I got when I opened Xcode once, and I dismissed it because I it's 30 days, I'll worry about it later. There was no 10-day warning, there was no 2-day warning. So anyway, taking care of it for you guys. I just tested it a minute ago, it worked. It's been working all day. Anyway, so I'm here to talk about robots. Who here loves robots? I'm sort of hijacking my own talk. I'm not going to play this video because I have the thing here, but if the thing doesn't work, I'm going to play the video. And before I tell you how it works, let's just, I'll talk you through it. So this is my iPhone, and hopefully I don't get any embarrassing tweets or texts. I don't have any at the moment, but I'm not going to tell you the one I got once. It was really bad. But anyways, it's in Do Not Disturb mode. You'll notice the moon. Let me shut this down. So I have over here, this is my screen mirrored, as you can see. And then in a second, I'm going to open Photo Booth so you guys can see the robot. But before I do this, let me explain what's going on. So, for those of you who use Appium, you may have noticed this little tab over here. It's the Robot Settings tab. And you may have wondered what's that there for. So Appium supports robots. This is one of two that work with Appium. There's an iPad version of this. And there's some other guy, I've heard rumors of other ones, but I've never seen them. But you can have Appium send all of your tap and touch events to a robot instead of to the automation framework. And so instead of simulating these events, your robot here will actually perform them for you. So I'm going to show you how it works. So first up, hopefully I will have it work. And then I will show you why it works and how it works, and put some very confusing equations on the board that I understood briefly when I wrote this thing. So let me just do that. Yeah, all right. So I'm going to launch a server on the robot. This is just a REST-based HTTP server that listens for commands. And you'll see I've configured Appium to send commands to that server. So it's on localhost 4242. Now I'm going to launch a test app we have with Appium on the phone using Appium. And you'll see as soon as it boots up, our app's going to load on the phone. And we've configured Appium to send all of our touch actions to the robot instead of to UI automation.js. That didn't look good at all. Okay, good. That was a lot of yellow. Wonderful. So you can see we've launched our test app on here. I will bring up the Appium inspector. You guys have all seen the inspector. So we're running a live session right now. So if you use the inspector, it will also send you tap and touch events. So I'm going to tell it to tap this box right there. And hopefully Let me get the photo booth up too. This is a delicate dance. So you guys can see that, right? Let's get it better. Right. Actually, let's get that above board. Back. There we go. Let's get a better view of this. Is that good now? I think that's pretty good, right? Tilt it down maybe. Yeah, that's about as good as we're going to get, I think. So I'm going to tell it to tap that box. And you see, the robot tapped that box. Not that impressive. But let me show you something a little more impressive. Let's have him type something. So we'll say, Vienna is better than Berlin. I think we can all agree. No? No? Yes. All right. I'll put exclamation point. I'll really test it. You know, hell, we'll put an @ sign in Vienna too. I'm really pushing my luck. All right, so let's do this. I'll bring up the camera. So you can see it is typing. Not the fastest thing in the world, but I was really lazy and just wrote the software the easiest way possible. This robot can actually be quite quick if we want it to be. Pretty cool. This is just using Appium. All you need to do is launch the robot. So your existing tests, they already work with this. I don't have a lengthy test to show you, but anything we tell the inspector to do, it will do. So I'm going to turn this off. I think you guys believe that that worked. Well, let's sort of go into how does it work. So I'm going to kill this session real quick, unless someone has an idea. But let's show you how all this comes together. So Appium is able to talk to the DOM, and it can ask the DOM, where are these elements on the screen? So this is the traditional top-based 0, 0 in the upper left-hand corner, you know, whatever, 480 by 800 in the bottom right. I guess you call it quadrant 4 style coordinates. But anyway, but this robot knows nothing about that. It's a robot in the physical world. That makes no sense to it. So how do you translate it? So what we do, we have an app in Appium. It's a calibration app. And I'll go ahead and load it up here. Oh, I went to sleep, didn't we? And what it does is it's just a blank app, and all it does is when you touch the screen, it prints the coordinates you touch. And what we're going to do is we're going to have the robot lower his finger in the center of its world until it sees coordinates on the phone. It's using Appium to see if that coordinate DOM element has a value, right? So this is still using Appium, but we're just going to keep lowering the finger, not knowing when it's going to touch the screen, and ask Appium when it touches the screen, because the DOM element will have a value. So let's do that. So I'm going to kill this server, and I'll launch it again without any calibration data. And then over here, I'm going to run calibrate.js, and then I'll output it to this file. And so this will lower the finger until it touches the screen. I don't need to adjust the arms, there's some fine tuning, but so here we go. You'll see the robot, he's slowly lowering his finger, and at some point, he's going to hit the screen and the coordinates pop up. It's going to record that. Now it's going to move in the positive Y direction and the positive X direction, take 2 more points. And then once it's done that, it sort of knows its way around the universe. It knows the scale of it, and it knows sort of the orientation of it. And it can build a transformation matrix to map any coordinate from iPhone screen coordinates to its coordinate system, which is roughly centimeters X, Y, and Z from origin. So like right now, I think the origin is technically in the middle of here. So this is at like negative, it's at 0, 0, X and Y, and the Z is negative 160 centimeters or something like that? Or 16 centimeters, sounds better. So now it's recorded these coordinates. If you want to look at them, they're spewed out in that big JSON blob. But now it's able to do this work for you. So I don't have to reboot the server, but the server's now loaded with calibration data. And if I go back and launch our test app again, it's going to be even more fine-tuned because I just calibrated it. So. There we go. Alright, if I launch the inspector again, it will. Should be able to tap whatever I need it to, so. I don't know, let's tap this show alert button. And you see, spot on. So anyways, that's what it is and how it works. And I will go into some more stuff about it. That's right, I can't actually tap that. It's just a video. So I'm going to shut this now. Shut this as well. We're going to go back to slides. Maybe. Actually, I'm going to show the video. So this is a video of us automating Twitter at a conference a year or so ago. I think this is Jason and I stayed up all night getting this to work. What? Oh, did I not put the video? I put a GIF in there. Well, anyways, there was a tweet sent. I must have copied the screenshot of the video. Let me dig up the video real quick, actually. I'm going to go off the grid here. I know this deck has the video in it. Let's do. Alright. Oh, is it playing? Right. This is definitely a video. So you'll see. Launches the Twitter app. This is using stream recognition. It's not using Appium, but we're automating the Twitter app with the robot. We don't have the Twitter source code, so we can't automate Twitter because iOS requires it. But on Android, since it's operating system level control, this would work with anything. So it just sent, I think that's the world's only robotically sent tweet, or first one, something like that. No one has ever challenged my claim on it, so I'm keep claiming it. Anyway, back to the other deck. So, sort of explain how it works. If you guys are into math, that's sort of the math. It's just a basic transformation matrix. Something at one point I understood, but you can basically build a translation matrix. You multiply your coordinates, they go from one system to another, take the inverse from the other way. It's not hard. So, if you want to learn more about any of this stuff, that's my Twitter handle, which you saw earlier. TapSureBot has a Twitter handle. They are for sale if you want one. It's probably about 75 to 100 euros in parts to build your own. It's totally open hardware, open source software. I wrote the software for this, by the way. A guy, a name you may recognize, Jason Huggins, built the hardware for it. And he owns a company called Tapster Robotics Incorporated that makes these things full-time now, as of a few months ago. But they're still open hardware, so if you have a 3D printer or have a friend who does, you can print your own. Arduino will run you maybe 30 euros, plastic another 30, and then there's some ball bearings and other stuff. But it's about 75 euros, 100 euros, something like that. Or if you want it pre-assembled, I think it's closer to 500, 600 for Jason to do it for you. So, totally up to you. I haven't checked the price too, so it could be like 1,000 by now, who knows. There used to be like 200, but he's got so much demand now he can go crazy. So anyways, if you want to find out more about how it works, that's the GitHub repo at TapsterBot or at Hugs for Jason. You guys may know Jason, he created Selenium, the thing that Appium is based on. You may have heard of it. So anyways, that was what I had to talk about. I guess I take questions if anyone has any questions. But
yeah, so we had a lot of time. So thank you. Thank you.